Today, I want to show you the best practice of how to script internet data at big scale and even build a agentic web scraper that can interact with browser just like human to complete web scraping tasks on Upwork autonomously. So web scraping is one industry that is dramatically disrupted by AI, especially in 2024. Traditionally, loads of internet business, especially like aggregator or e-commerce, will spend a huge amount of engineering resource on just scraping data from internet to making sure the price and offer is most competitive. And the way they normally do that is that they will mimic the web browser and make simple HTTP requests to the URL and get the HTML back. Then have real specific parsing functions written down to map out which DOM element that contains the information that they want. So it is very specific and custom built per website because each website structure is different. And whenever this website structure change, the previous script will generally not working. That's why this company spent a huge amount of engineering resource in just building and maintaining different scripting systems. But apart from those big internet company, if you just go to freelancer website like Upwork and search for web scraper, there are a huge amount of job postings every single hour where business want to hire someone to build a specific scraper that is really valuable to them. And the use case across multiple different categories, from leads generation, leads research, or they want to monitor and analyze competitor pricing, doing market research, getting job listing, and many more. So there's a huge amount of long tail use case that small and medium business are after, but couldn't really find a good cost-effective solution before. But with the latest development of large language model and agentic system, the cost of building such web scraper has been dramatically decreased. In fact, you can actually build a agentic scraper that can satisfy most of those Upwork tasks with just friction of time and cost of what it used to be. And today I will take you through some examples of how can we complete some of the tasks here. I will break that down into 3 different buckets, from simple and public website to some of the scraping workflow that require very complex web interactions. So first, let's talk about the public and simple websites. Those are the websites where it is not gated by authentication or payment. Think about like a Wikipedia page or different B2B company websites. Those websites traditionally is really hard to script because the structure is just so dynamic. So each one requires some kind of custom build still. And this kind of first thing that large language model really changed the game because it introduced 2 capabilities. One is the ability to extract structured information from messy unstructured data, which means you can just feed the large language model messy raw HTML, and it is able to race through the whole thing and extract useful information out of it. And with OpenAI's structured output feature, this type of data extraction became really reliable. You can just define very specific data structure that you want to capture, and it will be always 100% follow that structure. And on the other side, apart from the data extraction, you can also utilize agent reasoning ability to build more sophisticated scripting behavior. For example, if you're doing a B2B company research, sometimes the requirement and flow is a little bit more vague. You just have a company website, but you don't know which specific page contains the data that you want. But with large language models' agentic behavior, you can actually build a web scraper agent to be able to give a website and then navigate through multiple different pages until it finds the information that you want and eventually aggregate all the information together. So this type of large language model-based scraper agent is really powerful. But does that mean the web scraper problem has already been solved by this? Well, not exactly. Quite often, you will have websites that require complex web interaction to get the information that you want. For example, a lot of news websites will require subscription login to get the content out. And you might also have pop-ups on the website that stop you from getting the content. Not to mention all sorts of different anti-bot mechanisms like captcha. And for some data, it just requires multiple different actions to get the result you need. And for this type of website, we need a way to really simulate the human interaction to be able to get the data out. And this is the kind of second type of use case that I see. Those are websites that is a bit more complex, but the process of getting that data can be pretty specific and repetitive. And this type of use case actually catered for 70 to 80% different use cases that I saw on Upwork. And I'm going to show you an example how do we do it. In the end, there are a third type of use case that I see that require not only the web interaction simulation, but also complex reasoning tasks. For example, the user request here would be more vague, like find me the cheapest flight for the next 2 months to Melbourne, or buy tickets of a specific concert within specific budget and time period. This type of use case will require much more sophisticated agentic reasoning ability, and it is a lot more experimental from my experience. But there are also platforms that are experimenting this type of frontier use case. I'm going to take you through my best practice of how to implement web scraping for each individual categories. So first, let's talk about best practice of scraping the public and simple websites. As we mentioned before, with help of OpenAI structured output feature, we can extract structured information from the raw website HTML and also build some agentic system that can navigate through multiple different pages to get the information that you're looking for. So before 2024, most of people are just feeding the raw HTML to large language model. And often it does work. But because raw HTML has a lot of noise, the result can be inaccurate. And also you will spend a lot more since it is burning more tokens. But this year we start seeing emerging of different service that is providing large language model optimized web content. This category of service will start by file crawl. So if I give a website URL, instead of returning raw HTML, it can turn into markdown file that is a lot more human readable, which means it will be easier for large language model to consume as well. And now there are a few different players and service that providing this that's aimed to dramatically optimize the web content for large language model and agents. So apart from file crawl, there's also Gina. Gina introduced a Reader API, which is doing very similar things. But what's really interesting about Gina AI is that if your volume is small, it's basically free to use. They have an API that doesn't even require authentication. You can just go to any website, add HTTPs, and add r.gina.ai. And this will automatically turn the website page into a markdown format just like this. It's pretty insane that you can just use this for free without any kind of API key. I don't know who is paying the bill, but unless your volume is bigger, they don't really charge you. And on the other hand, there's also a platform called Spider Cloud. So when I was putting FileCrawl and Gina into production, I sometimes got a problem that there are a spike of usage. Gina and FileCrawl, it will just arrow out and couldn't return any website content. But Spider Cloud supports script 50K pages per minute, which is kind of insane amount of rate limit. And on the other hand, even though the content from each service are all marked down, but there are still slight difference. For example, I try to use both services to script a local restaurant near my place, and you can see the result it returned from different services are slightly different. You can see that FileCrawl has 116 lines of markdown file, and Gina is 59 lines of markdown, while Spider Cloud is 68 lines of markdown. From my observation, FileCrawl tend to keep as much information as possible from the website, whereas Gina API try to really focus on the main text content itself. And Spider Cloud is somewhere in between. It will try to keep the link and also turn into really kind of human readable markdown format. So in general, there's some difference in terms of content return as well. You can choose the one that suits you best based on use case. And in the end, they also cost. So the cost per 100-page scripting, as we mentioned before, Gina is basically free. Spider Cloud is around 3 cents per 100 page, and FileCrawl will be around 6 cents per 100 page if you are on their highest tier. And here's an example of agentic scripper I created before, where I can use FileCrawl to get the markdown data from a website and then use GPT-O model to extract specific information that I care about. And it is able to race through multiple different pages to get the full menu items across website into JSON data like left side. And there are more kind of features you can optimize for this type of agent, like optimize how the agent memory should be stored so that it can script bigger and bigger amount of data. And remember what URLs it already scripted before so that it won't take the same action again, as well as integrated with new data source like Llama PDF parser or EXA search. If you're interested, you can join my community where I have ready-to-use agent template for web scraping and research with detailed code breakdown. So feel free to click on the link below to join my community and get agent template. So this is the first type of website that is public and simple, where you can simply build agent to script the content. And next is those website that is not that simple and require some kind of complex web interactions, where they might have pop-up that blocking the content or require login authentication, or you might need to interact with pagination to get the full content. To deal with those websites, we actually need to mimic a human interaction with the web browser. And to simulate those website interaction, it is commonly done by package like Selenium, Puppeteer, and Playwright. Those packages are initially designed for web app QA testing, but now can be used for those agentic scripper. But the hard part of building an agentic scripper that can simulate web interaction is how to locate the right UI element to interact with. For example, if you want web agent to be able to type in the search box for your location, you need an effective way for the agent to communicate with web browser which input is the search box. And some of the website can be even more complicated, like this login page of LinkedIn. It has 3 different sign-in buttons. So if you just simply give large language model the whole web page and ask it to extract the right UI elements to interact with, it often didn't work. And this is where I found a package called agentql comes really handy. They basically build a model to be able to identify the right UI elements to interact with, as well as the right DOM that contain the information that we want, so that we can give the right instruction to Playwright to simulate the web interactions. And this allowed us to do a whole bunch of web automation, like close different sorts of pop-up window and cookie dialog, as well as logging websites that require authentications. All I need to do is just using their SDK and pass on the UI elements that I want to get back with natural language, and to showcase how can you fully utilize agentql to build such web scraping. I thought it would be interesting to showcase how can we deliver the scraper for some of Upwork job here. So this one from 3 weeks ago, where they want to build a scraper for a website called Idealist, which looks like a job market for nonprofit and volunteer work. And they want to pull all the jobs that has been advertised every week and get a big list including the org name, job title, salary, so that they can easily sort by type of role and location to help clients do a better job in terms of setting salaries. If I go to Idealist, you can see this website actually requires you to log in to use the populate. So I will quickly create an account. And login firm also has a bit kind of anti-bot practice with a I'm not robot checkbox. And we will also showcase how can you get through that as well. And after we get into it, it has a list of different jobs with pagination. So we need to learn how to use agentql to extract the job detail data here and navigate through different pagination. So to get started, we can create an account on agentql. And first, let's download their Chrome plugin to get a sense about how does it actually work. After we install the extension, we can go to the website that we want to script and open the inspection by right click. Now you will have a new tab here called agentql. We need to put our API key here, which you will get from agentql website. And now we can start experimenting. So we just need to pass on query of the items that we want to capture. For example, if we want to get the number of jobs results, I can just put something here called number of job posts total and fetch data. Then you will see that it returns the data 3,258, which is what we have here. But on the other side, we can also define an array as well. In this case, I can define job posts and putting the array symbol here. And inside each job post, I want to know about the org name, job title, location, salary, contract type, and remote type. And for some of the items that might not be self-explaining enough, I can add further description as well. So for contract type, I can define full-time or contract or part-time and click on fetch data. Below that, you can see the result. Extract all the job posts on that specific page with company name, the job title, location, salary, and contract type, remote type. So this plugin allows us to just debug and test what type of query can actually work and return the result you want. On the other hand, we also want to test whether they can locate the whole login flow UI elements. So this time I'm going to try login form, email input, and continue button. So it'll be useful to give a structure so that agentql will know that it needs to get the continue button within the login form instead of or any other buttons. So let's try to fetch web elements. Okay, great. So you can see that it returned 2 UI elements. One is email input, one is continue button successfully. So this looks really promising. Now we can start actually go to the Python to build out the automation that it can log in to the website. So I will start a GitHub repo and open the folder in Cursor. Let's firstly install agentql. So I will set up a new virtual environment first. So since I'm in Cursor, I can do Command K, set up a new Python environment. Then it will automatically generate the command line for me or enter. So now we are in this new environment. And first thing I will need to do, I will copy this to install agentql and initiate the project. And then I will create a .env file. In here, I will put the agentql API key, as well as the email and password for logging the ID list. And after that, I will create a scripper.py, or import a few different libraries that we're going to use, and then load the environment variables that we just put in here. So firstly, we want to build a script that can locate the email input and type in the email input. Then click on this I am not robot checkbox and click on continue. To do that, I will first define the initial URL as well as a query called email input query. So this will require the login form with email input and continue button. And you can see that I didn't really include the I'm not robot checkbox because at the beginning, that UI element is not showing up on the screen. So we actually need to create another one called verify query to get this verify not robot checkbox. So now we can try it out. I will start a web session first in Playwright and then start a new page with agentql. Firstly, do page.goto to go to URL, and then try to query the email input form. Then I will ask it to put the email address into the email input field. Wait for 1000 milliseconds for the verified human UI element show up. Then I'm going to query that specific element. Then ask AI to check that I'm not a robot checkbox to see if it works. And in the end, click on the continue button to log in. So let's try it out. I will save this and then open the terminal, python scripper.py. And it looks like I need to install the .env. So I can again open the command K and give the error message, no module name .env, and click submit. And now let's try to run this. Okay, I got this arrow. Looks like I need to install Playwright. So I will do Playwright install. And again, Playwright is a library that we're going to use that can simulate web browser sessions. Okay, now the installation is done. Let me try to run this again. So you can see that it opened a new browser. It also locates the email input and type in the email address. And after the I'm not robot checkbox show up, it tried to select the checkbox and click on the login button. Next, the password input show up. So this is working, and it's actually kind of hilarious that it is able to click on the I'm not a robot checkbox easily. So if you're building a website, don't rely on that as a mechanism to anti-bot. So I'm going to add the last query for this login function called password input. I will try to query the password input, fill in the password there, wait for a second, and click on the continue button. And in the end, it will wait for the login to finish. And after that, I will also add something called browser.context storage state to save this login state as a file that we can load in later, so that we don't need to repeat this kind of login process again and again. And just for demo purpose, I'll add some waiting time in the end so we can see the result. So again, type in the email address, click on I'm not robot button, click on login, the password, click on login again. Great. So it has logged into this platform successfully with my password and email. And you will see that this is a file called idealist login.json, which will store the login state so that we can load in later. And I'm just going to wrap this whole thing under a function called login and start a new session for the main function to script job posts. And then I'll do if the file doesn't exist, then call this login function. If it does exist, then we want to load the file directly so we don't need to log in again. Then we'll load the state and then go to the URL, which is something we define here, to job posting page. So that's pretty much it. And then we'll try to call this function that we just defined here. Now we can build the rest of the script to get the full job posting content across multiple different paginations. So I'll create two new queries. One is a job post query that we tested in the Chrome extension before. Another is pagination query, because we want to get the next page button as well, so the agent can go to next page. And then our first setup status equal to true and get the current URL before we click on the next page button. And we'll firstly try to get the job posting data from agentql. And after getting that data, we also want to get pagination and click on the next page button. And after we wait for finish, then we'll check if the URL actually changed. Because if the URL changed, that means we are not at the last page yet. So it will continue going until we script every single page. So that's pretty much it. We can try to open the terminal and python scripper.py. In the end, for the job posting data, I also want to save it to Airtable or Google Sheet. So I'm going to add some new credential for Airtable in the .env file, which is API key, base ID, and table name. If you're not familiar with Airtable API, you can basically create an Airtable. Base ID is basically this part of the URL, and table ID is the one after start with TBL. So you just need to copy these two things over and then go to the Builder Hub, create a new token, give a name, agentql, add a scope. We will need the write and the read and access to the full workspace. Then can copy over the API key and put in here. Then I will import a new package called py Airtable. If you haven't installed that, making sure you open terminal and do pip install, then load those credentials in. And we're going to create one function called push data to Airtable, where we will take a list of JSON and save the data to this Airtable. In the end, we're going to go to the main function and call this push to Airtable function. That's pretty much it. So you open the idea list and should be start scripting. And meanwhile, just let me open Airtable to see things side by side, whether it start adding information. Okay, great. So on the right side, you can see the information is automatically pushed in. While some of them salaries seem to be empty, but looks like there are some jobs that actually didn't have the salary data. That's probably why. And once the one page is finished, it will navigate to the next page and keep adding new data in until it finish all the pages. So this is a pretty dope automation that it's actually pretty hard to do since it touches multiple different parts. And the best part is that the script we built here can automatically apply to other job posting websites because the process and workflow are going to be very similar, where it will do the login and handling the pagination to script the full job posting data. And what you can do after is just schedule a job every hour or every day to keep updating the data in the Airtable. But this is just one example. You can imagine there's so many web automation you can do, like collecting and comparing pricing data from different e-commerce websites and many more. So this is the second category of those complex websites, but has a pretty predictable and known process. As I mentioned before, this second category probably cater for 60 to 80% of different jobs and requests that I saw people posting already. But the last category is those type of scenario where users' request is a bit vague, not a very clearly defined step-by-step workflow. For example, you might want it to go find the cheapest flight for during certain period of time for you. So this type of workflow is much more complex and requires some kind of reasoning and planning ability to decide where to go next. And from my experience, this type of workflow is very hard to do, but there are companies that are exploring those kind of frontier workflows. And the best one is probably Multion, where they focus on building this type of web agent that is autonomously operating the web browser. For example, I can actually go ask to book a ticket for me and complete the whole workflow. So I can just copy this URL over and then say, book the ticket for me. So you can see it automatically choose the venue and date, click on the next button, go to this ticket selecting page, and it was able to select a ticket and adding a ticket for me as well at top. And move all the way to the bottom, and you can see they try to find the next button, but for some reason stuck there. Okay, and eventually find the next button, click on it, and then stuck at this page. So you can see that this type of fully autonomous web agent still have a long way to go to be super useful, but it is actually pretty impressive. It is able to go through multiple different hurdles of this web form. And they also offer an API for you to use as well. So there are loads of opportunities since most people didn't realize how easy it is to build at the moment. Those are my best practice about how to use agent and large language model to do the web scraping in 2024. But definitely recommend you go and try out. On the other hand, if you want to dive a bit deeper into this topic or have some specific question that you need help with, you can go join my community where we have full detailed step-by-step code breakdown of those different type of web scraper agents with ready-to-use templates that you can just copy-paste, plug and play. And more importantly, you can join a community of other top AI builders who might already experience the problem that you are having now. So you can just post and get some help. I'll continue posting interesting AI experiments I'm doing. So please like and subscribe if you want to get updates. Thank you, and I'll see you next time.